Now how do I do this? A minus b to the power 3 is a to the power 3 minus 3a square b plus 3ab square minus b to the power 3. Now, how do I draw this calculation or this conclusion from this calculation? Well, I can write it in the above format in a reduced form, which is a to the power 3 minus 3a b a minus b minus b cube. I would write the above terms in the similar fashion in order to explain it even better. A to the power 3 is a to the power 3, 3a into b plus 3a into b into b. Now we see 3a and b is common here, 3a and b is common here, minus b cube. So I take all the common signs together and put them up in the previous fashion, minus 3ab. Now see, when I take a minus from here, I put a minus here inside the equation. So remaining is a here, I put minus here, so minus remaining b, minus b square. Now the question is, if there was plus, why do I put a minus? I put a minus inside the bracket, not outside, because when we open it up, minus 3, when I multiply with minus b, minus 3ab, it gives the same old number, 3ab square. That's why I do it. Now the question is, if they are like that, I mean the equation a minus b whole cube is expanded as a to the power 3 minus 3a square b plus 3ab square minus b cube. How do we come to this conclusion? Well, it's very easy. It's very easy. How do we do that? Well, let me show you. We already did the equation as a plus b whole square is equal to a square plus twice twice a b plus b square. We know this. And how do we know this? So we need to find out here a plus b whole cube. We need to prove. I'm going to prove it. How do we come to this conclusion? But first, I'll have to prove you this. And how do I do that? This conclusion we draw by basic expansion. You see, a plus b square, it means a plus b 1 to the power 1 plus 1, which can be written as a plus b into a plus b. I think everyone is quite clear on this part. Now, in this equation, I am trying to multiply a plus b with a plus b. And how would it be if I individually multiply them? I first take a and multiply with a plus b. A into a plus b. And then I take b plus b and I multiply with a plus b. A plus b. So I go on to opening the brackets. A into a is equal to a square. A into b is equal to ab. I open another bracket. B into a is ba. B into b plus b square. Now if I rearrange these terms, I get a square plus twice ab. plus b square, which is the above result that we got here, which is the RHS in this situation. Now our target is to deduce what is the result for a plus b whole to the power 3. Now we go in the same technique. We do it one by one. How do we do it? A plus b whole to the power 3 it can be written as a plus b to the power 1 into 1 into 1. Now it can also be written as a plus b to the 1 to the power 1 into 2. Now this I can write as a to the power a plus b to the power 1 into a plus b to the power 2. Now we already deduced this in the previous scenario. We already deduced this, so we can write it again as a plus b. We already know the value of a plus b whole to the power 2, or a plus b whole square, which is a square plus twice ab plus b square. Now this equation, we are going to expand it. First we multiply all the variables with a, then we put a plus sign, then we multiply all the variables with b, which is this way: a into a square plus twice ab plus b square plus b into a square plus twice ab plus b square. Now if I expand them, I get a into a square, a to the power 3, a into twice ab, 2a square b. When I multiply the similar variables, they add in powers. Again, when I multiply a into b square, I get a b square. When I multiply b into a square, I get ba square. When I multiply b into twice ab, I get 2ab square. When I multiply b into b square, I get b cube. Now here I rearrange all the variables. A to the power 3 is a to the power 3, 2ab square and I rearrange this, plus 2ab square plus a square b. 2a square b plus 2a square b, and here plus ab square plus 2ab square plus 3b cube. Now we add all the common terms. A to the power 3 plus 2ab square plus ab square is 3a square b. We also add these common terms. ab square plus 2ab square is 3ab square, and at the end is b cube. Now we see we have already deduced in the previous question that we wanted to know how do we come to this equation: a plus b whole cube is equal to a cube plus thrice ab into a plus b cube, which I have already written before, and we also have got deduction for that, which is I explain here how we came to the conclusion a plus b whole cube is equal to a cube plus thrice ab a square b plus ab square plus b cube, which is what we got here. Now we move on to prove the next question, or next number. A minus b whole square is equal to a square minus twice ab plus b square. How do we get it? So we prove it. How do we prove it? Simply, just in the same situation, we remove the plus sign from here into minus sign in here, and we write them in a simple form as a minus b to the power 1 plus 1, which can be expanded as a minus b 1 into to the power 1 into a minus b to the power 1, which means a minus b into a minus b. Now I can expand them by just one by one, a into a minus b, a into a minus b. Then there's a minus sign, minus b, and I expand using b, and inside whatever is inside this bracket, b into a minus b, a minus b. Now I go on to expanding them, which is a into a square, a into minus b is minus ab, minus b into a. I can rearrange and write them minus ab, also minus b into minus b is plus b square. Now for understanding, I would write a few equations for our understanding's sake. Plus into plus is always plus sign at the end. These are two similar signs. Minus into minus, minus into minus is also plus. So there's the hint. When there are both pluses, you multiply, you get a plus. When there are two minuses, you get a plus. But on the other hand, if you have minus into plus, the result is minus. Or if you have plus into minus, the result is minus. So we need to somehow remember this. The success to mathematics is to remember the sequences, the numbers, and the formulas with practice, of course, not in a single day. So we get in this equation a square minus ab plus b square, which can be in a short form written as b square minus twice ab, because they were minus ab, which is minus 2ab plus b square. So this is the RHS in the above question, which is what we prove now. We move on to the next equation, which is how do we deduce a minus b whole to the power 3? How do we find the results?